Good afternoon to everybody. My name is Luca Ferretti, and I will present my fourth year of research here in the University of Modena. And my tutor is Professor Michele Colajanni, and my research topic is security solutions for cloud-based services in the future internet. My research involved the study of the problem of data outsourcing to cloud-based services. And what is the problem of this topic? That in normal, well, it does not work, okay. In normal infrastructures where we do not outsource data, we must protect the data against only external attackers. And in cloud-based services, we must protect data confidentiality against also the cloud provider and the cloud provider employees. And we have advanced threat models of users, internal users that collude with the cloud provider. So in this context, the common solution is to encrypt data at the trusted side, and then store encrypted data in cloud services. However, my research studied the problem of making use of databases that support the execution of complex queries against multiple users with different access control on data and that may execute queries and data modifications on the database. So this is the architecture design of my proposal, in which we have the multiple users and that execute SQL operations on the data. And we consider a tenant company with a database administrator that manages access control policies, high-level access control policies defined by the tenant previously, and that define and the database administrator gives to each user unique credentials that make them access only data on which they have legitimate access. So, existing architectures that propose that make it possible to execute queries on encrypted data make use of complex encryption schemes that make it possible to transform plain query to encrypted query quite in the same way as if the data were plain text. And in this context, there exists a famous solution that is the full homomorphic encryption that allows to execute any computation on data. However, that encryption scheme is not practical computationally. And so many other schemes have been developed to execute only some computation on data. However, they are practical and they allow to obtain acceptable computational overheads. So my research focused on developing a novel architecture because these schemes require to distribute much more metadata to the trusted clients and also the encryption keys. And so this is the fourth scheme of my architecture that store metadata and encryption keys on the database in an encrypted form. And then the users make use of client machine to retrieve metadata, cache them locally, and execute the queries on encrypted data using the previously showed schemes. My metadata design make it possible to reduce additional conflicts against multiple concurrent modification on the data and also on the structure of the database. And this is, in this figure, we demonstrates how data are encrypted using different algorithms and tables and columns that must support join operations share the same key. And furthermore, the multiple users use different credentials, and they developed a derivation scheme, a novel model, in which the plaintext database is in which that database expressed the access control policies is transformed into an encrypted database, and any access control rule on the plaintext database can be expressed on the encrypted database. And here we have that each structure of the plaintext database is translated into an access group in the encrypted database, and the encrypted access group are linked with cryptographic information that allow to optimize the number of encryption keys. And then encryption groups identify data that are encrypted with the same encryption key. And so we have the two columns that are of two tables share the same encryption key and can support join operations. I developed my architecture I developed my architecture in Python, and we tested that in emulated network environment under the TPC-C workload. And the figure on the left shows that in the TPC-C workload, only few queries makes use of highly computational encryption schemes. And as a result, the overhead is acceptable when multiple clients access the database with regional latencies. And also the scalability of the database is not affected by our solution. And these figures show that with almost no latency, the overhead of our solution is quite heavy. However, when you access the database geographically, you have internet latencies that mask the encryption overhead. And so this solution is really practical in cloud databases. This is the list of my publications, and thank you for your attention. I'm available for any questions.
Oh, I attended a tutorial by Amrel Abadi from University of California, and in this tutorial, he is a database professor. He's saying that the cost of translating for very strict and secure encryption strategy data is very, very, very high in terms of computation. Just when you have a database application with managing a lot of data, it's infeasible to encrypt data. What can you tell me about this issue?
Well, the encryption scheme that you may, the many encryption schemes exist that you may use to encrypt databases. In my architecture, I considered encryption schemes, the one that I showed in the slides.
Non-scheme data.
Yes, the scheme includes also data. And in my scheme, in my strategy, data are encrypted by field. So each value of the database is encrypted into an encrypted value. And the same indexes can be used the same indexes used in the plaintext database can be used to retrieve data in the encrypted database. And this allows to obtain highly efficient encrypted databases. So maybe the encryption schemes that the professor taking into consideration are maybe are more computational, are more heavy, but they guarantee more confidentiality, because these schemes may leak some information like the order of the data, and so it depends on the threat model that you consider in your outsourcing. So in my scheme, I consider that for example, the cloud provider does not modify any data, and so he only tries to access the data without modifying the protocols. So it's called semi-honest and not a malicious cloud provider. So it depends on the type of encryptions, because there are many schemes that have been proposed depending on the threat model.